Hello there, and then welcome to a brand new video. This is Hub Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at the travel time, also known as the distance time graph. And by the end of this lesson, you should be able to read and interpret a distance time graph. You'll be able to identify the periods that we have in them, and then describe generally using these appropriate vocabularies. Without much ado, let's quickly look into it. So as you can see here on the screen, this is just a look of how a typical travel time graph looks like. Okay, so I'll explain all the parts so that you know what to do when you want to represent your story or your travel time on a graph. So to start with, we normally let this be our x-axis, right? This is our x-axis, yes. But on the travel time graph, that is where you indicate your time. You see, so it represents your time, as you can see here. And time in what units? It could be in seconds, you could have it in minutes or hours, depending on your preference. Okay, then we have the axis here, which we usually call the y-axis. But on the travel time graph, we use it to represent the distance from the starting point. And usually here, this side is our starting point, and it has a coordinate of 0 time and then 0 distance. That is your initial point before the whole story begins. Okay, so at this point, which is your starting point, time is 0 and distance is also 0. Now this graph here represents some types of motions that are worth noting. Okay, so the straight line upward, that is this part here and then this part here, you see, they represent moving at a constant speed. That is from your initial position. You see, so if this here is if let's say this point here is my initial position, okay, then this straight line upwards is trying to say you are moving at a constant speed from this point. You get it? So moving at a constant speed from your initial point. That is what these lines here, this one here, and then this one, they are all talking of what? Constant speed upwards from your initial point. Then you realize that there are also some horizontal flat lines as well, these ones here. Okay, so for these two horizontal lines, they represent no movement at all. They represent no movement. So if you see horizontal lines on your distance time graph, then it means there's nothing moving, especially distance. There's no distance moving. Well, time always moves, but then the distance is constant. What do we mean by that? So initially, I said that this was your initial point. Okay. And then we have also said that this straight line upwards means you are moving from your horizontal, from your initial point. So as you have moved from your initial point to this distance over here, this distance here. So let's say you moved from your house, you see, and then you came to a shop. So at this shop, you are staying there for a while buying some groceries and all that. So in that case, there is no movement away from the shop. You are still at the shop. Now, as you are still at the shop, you realize that it corresponds to a particular time over here. You see, so from 0, you move to the shop, which might be 10 meters away from the initial position here. Now you moved at a time of, let's say, 5 minutes. You see, now away from your house, you are still at the shop, which is 10 meters away from your house. Do you see that? But then you are staying there for a number of time. So let's say for about 15 more minutes. You get it? And that is this time span we have over here. You see? So you realize that the time is still moving though, but your distance remains the same. You are still at the shop. You get it? So we are saying that the flat horizontal line represents no movement. That is, you're at rest or stationary. Then we come to the last set of line over here. And then that is this one you see over here. You see? Now this one is a straight line downwards. So it means that you are moving back to your initial position. You are moving back to your initial position, because if you look at the corresponding point here to the distance, it comes back to 0. You see? So you are coming back from your initial position. We use what? The horizontal, the straight line downwards. So with these explanations, let's see how we actually use them. Okay, let's look at how we actually use them. So looking at this first question here, it says a boy walks from home to a friend's house 4 meters away in 30 minutes. You see, he does that in 30 minutes. Now, he rests for 60 minutes and then walks back in 45 minutes. So we have to represent this on the what? Distance time graph. Now, to do that, you need your graph sheet. Okay. Then with your graph sheet, you'd have to label your x and y axis. You do that depending on the unit you have. Okay. So for what I have here, I know my maximum is 4. So if I'm able to evenly space out my graph sheet and I have 1, 2, 3, 4, and even add a 5, everything, it will be within the range of what? My work. Secondly, I have what? 30 minutes and then 60 minutes and then 45 minutes. If I'm to add all that, I should know where my limit should be. You get it? So with all this, you try and then get your own skill. That will make your work presentable and then visible as well. Now, we said earlier on that 0, 0 here is your initial point. So if this is our initial point, the boy walked somewhere or to his friend's house, which is 4 meters away. So we want to get here. This is the 4 meters away. This is 4. That is our distance in meters. 4 meters away in 30 minutes. So 4 and then 30. Where do they both meet? They both meet over here. You get it? So let me use a better line for that representation. So this here is my 4. You get that? And this here is my 30 minutes. You see? So where they both meet at, we are going to draw a straight line to touch that point. You get that? So that is the representation of the first statement. You see? Which says that he walks to a friend's house 4 meters away. So this is the 4 meters we have represented. And then in 30 minutes, so this here is our 30 minutes. Now he rests for 60 minutes. We don't know what he's actually doing. Maybe, yeah, we are being told that he rests for 60 minutes. So at this point, there is no distance increasing or decreasing, but it's just a rest. You see? So we said that our horizontal line represents the rest. Now, per our scale on the time axis, we have what? 30-minute intervals. So if you rest for 60 minutes, then from this 30, our initial 30 plus another 30 would be what? Our 60 minutes. Remember, you are on 30 minutes. You see, this over here, you're on 30 minutes. So if you add 60 more minutes, which indicates his rest period, then you're going to be on what? A 90. You get it? So this is his new what? The new coordinate. Now he walks back in 45 minutes. So right after the rest, he's coming back to his initial position, which is 0, in 45 minutes. So if we are here and we want to add 45 more minutes, then that is going to be what? That is going to be his initial time he has now. So let's take a look at what the time he has now. You see, so he's at 90, then plus our 45, which is going to give us a 135. You see, so with that now, All we have to do is to draw our line from this initial point to 135. Since our intervals are 30 in that order, so 30, 30, 30, our 45 or our 135 is going to be between what? The 120 and then 150. That is just it for the story we have over here. So drawing these graphs are very, very simple. This here is an introductory video and I wouldn't spend much time solving other related questions. But if you have understood this, then I'll upload another video, or you can just check the playlist where we take more that involves questions such as the distance, how long the entire journey was, the velocity, and then all that. If this is your first time on this channel, this is how Beyond Numbers, where we learn maths the easy way. You can choose to subscribe, that is if you so do wish, so that anytime I release any maths related content, you'll be notified as well. Stay blessed.